As cool as Jurassic Park sounds, the average paleontologist will tell you that there's no hope of ever actually getting dinosaur DNA, and the reason they say this is quite simple. Dinosaurs are supposed to have died out 66 million years ago. DNA does not last millions of years, therefore, dinosaur DNA does not exist. Case closed. My name is Joel Brown. I'm with the Creation Research Society, a member of the Logos Research Associates, and I'm representing a group of scientists. It's not just us. There's a number of scientists, creation scientists, that are working on this project of finding dinosaur DNA, and we believe it exists. We would predict that it exists based on these 3 lines of evidence. Number 1, we have found, and others have found, inside of dinosaur fossils, soft tissue, soft organic tissue, such as proteins. This suggests that these fossils may not be as old as they are reported to be. Number 2, inside of these intact cells, there have been markers of DNA reported. So it looks like there is still some remnant DNA from the original organism inside of these dinosaur bones. Number 3, and most importantly, we're approaching this from a different worldview. We don't believe these bones are as old as they are reported. We believe they are thousands, not millions of years old. If that's the case, DNA can last for thousands of years. This is well established. It doesn't last forever, it doesn't last millions of years, but it can last thousands of years. Because of these 3 lines of evidence, we predict that dinosaur DNA is out there in the right bone under the right preservation conditions. This will not be a simple task, because even after thousands of years, DNA has undergone a lot of damage and decay and degradation, and it's therefore difficult to extract and work with it. So how do you sequence dinosaur DNA? It would look something like this. Step number 1 is acquiring the right sample. Now we're going to start by just trying to sequence and extract DNA from any sample we can get our hands on. We take about 300 milligrams of the fossil and we try to extract the DNA from that. Other folks in the team have optimized the DNA extraction methods that are used, and we're still working on these to get as much potential dinosaur DNA out of these fossils as possible. So that's phase 1, is sample acquisition, optimizing our methods for extracting the DNA. From there, we go on to sequencing the DNA. We're using nanopore sequencing that's able to take individual strands of DNA by the thousands and run them through these tiny pores and extract the sequence information from them. Sequencing the DNA is the easy part. The challenge actually comes after that, when you have to try to figure out what is the real DNA from the organism and what is contamination. We expect contamination wherever you go. Any piece of dirt that you dig up in this world is going to have DNA in it. Environmental DNA, bacterial DNA, those are things we're not interested in. So phase 2 is sorting through all of this sequencing data and trying to extract meaningful sequence from the dinosaur itself. Once we can extract and sequence verifiable dinosaur DNA, then we want to sequence a bunch of samples from the same species of dinosaur, take all the different sequences from those different samples and start to patch them together to assemble a rudimentary dinosaur genome. Our goal is not to prove that these dinosaur bones are young. We're just curious scientists that would like to know about the genetic code behind these most interesting and amazing creatures that God created. And we believe it's possible because they are young. This is a large undertaking that involves many researchers from several different universities, and it's going to take a lot of time, a lot of personnel, and a lot of money. So we're asking for your help. The funds that you donate will go towards, of course, acquiring samples. It's going to go towards the supplies needed to extract the DNA, sequence these samples, an expensive undertaking. It's going to go towards students, paying students to do this work. This is heavily reliant on boots on the ground, and those come in the form of undergraduate students in many of our universities. It's going to come in the form of actually managing the data. That's an expensive task of sorting through all this data. That's called bioinformatics. So please consider supporting this important and interesting and exciting endeavor as we pursue dinosaur DNA.